Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is a part 3 video from the chapter of coordinate geometry where I will be solving the last set number 3 of multiple choice multiple choice questions from the MCQs Practice Exercise supplementary book of author R.D. Sharma. This video is part of the playlist CBSE Maths for, for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so the first problem says that the area of the triangle formed by the point minus 3 comma 4 and its reflections in the coordinate axis is. So uh, for triangle we need 3 points. One of the point is given as P, that is minus 3 comma 4, and its reflections, one image, the other two vertices will be one will be the image of this point P on the in the x-axis, and the other vertex will be the image of this point P in the y-axis. So let's see how the triangle will look like. So let's draw the Cartesian coordinate axis. This is y origin, y dash, x dash, x. So roughly let's plot the point P. It is abscissa is negative, that is minus 3, so it will be, the point will be on the left hand side in the negative direction of the x-axis, or to the left hand side of the axis of the y-axis, and it will be at a distance 3 from the y-axis, and the ordinate or the y coordinate is 4, which is positive, which means it will be at a distance of 4 in the positive direction of the y. So roughly it will it will be, let's say, over here. So this is the point P minus 3 comma 4 minus 3 comma 4. Now what will be the image of this point in the x-axis? So it will be a point on the line which is perpendicular to the x-axis and passing through the point P, and it will be, the point will be, the image of P will be on the other side of the x-axis at the same distance of 3 from the x-axis, at the same distance of 4 from the x-axis. This point P is at a distance of 4 from the x-axis, but it is in the positive direction of y. So the image of P in the x-axis will be somewhere over here. Q, let's say this is let's say this is Q. The image of P is Q. It will be below the x-axis and at a distance of same distance of 4, but it will be in the negative direction of the y, so it will be minus 4, ordinate will be minus 4, but the abscissa will be same, x coordinate will be same. Okay, what will be the image of the point P in the y-axis? It will be its image will be, since the point P is to the left hand side of the, is in the negative direction of x, the image of P will be in the positive direction of x, and it will be at a distance of 3 from the y-axis. So roughly this will be somewhere over here. Let's say this is R. So this is 3 and 4. So now we have to find the area of the triangle PQR. So let's join the points PQR. Now remember one thing, that okay, now whether if when I'm joining the points Q and R, the line will actually pass through the origin. It will actually pass through the origin because the point R is 3 comma 4 and the point Q is minus 3 comma minus 4. It is so you can see that it will okay. So let's forget about whether whether the line QR or whether the side QR will pass to the origin or not. That is not important. But one thing, so how will I compute the area of this triangle PQR? Clearly, PQ, the angle P, that is PQ and PR, the sides PQ and PR are perpendicular to each other. Why? Because the side PR, when I am joined the line segment PR, it is parallel to the x-axis. It is parallel to the x-axis. Why? Because the ordinates of the point P and Q, P and R, they are same. That is also because when you draw image of P, if R is the image of P along the y-axis, in the y-axis, then obviously the PR will be parallel to x-axis. Similarly, PQ is the image of P in the x-axis, which means PQ will be parallel to y-axis. So since x-axis y-axis, they are perpendicular to each other, that's the reason PR, which is parallel to x-axis, and PQ, which is parallel to y-axis, they will also be perpendicular to each other. So this triangle PQR is a right angle triangle, and I can find the area of the triangle PQR by applying the formula half into base. I can consider the base to be either PR or PQ. Let's consider the base to be PQ. So what will be what is the distance between the point P and Q? It will be so both the point P. So let's say PQ is intersecting the x-axis at the point T. So PQ. So the distance, the area will be PQ multiplied by PR. Now, what is PQ? PQ, I can write it as twice PT. I can write it as PT plus TQ multiplied by PR. Okay. Now, PT, P is at a distance. The distance of PT and TQ, they are equal because the distance of P and Q, they are both at the same distance of 4 from the point T. The distance of the point P and Q from the x-axis is same as the distance of the point P and Q from the point T. So this will be twice, I can say PT, and I have PR. So this becomes PT into PR. Now what is PT? What is PT? PT is the distance of the point P from the point T or from the x-axis, which will be equal to the ordinate of the point P. So this is 4 multiplied by what is PR? PR is the distance between the point P and R. Now both the points P and R are having the same ordinate. So whenever two points having the same ordinate, the distance between them is equal to the absolute difference, the absolute value of the difference of the x coordinates or the abscissa. So I can say this will be, if I take the difference of the abscissa or the x coordinates of point P and R, it will be minus 3 minus 3. So this is 4 multiplied by, this is mod operator, the parallel lines, this is the mod operator or the absolute value or the numerical value. So this is 9 minus 6. So this is equals to 4 into 6, which is equal to 24. 24 square units. All the lengths, that is a length in Cartesian coordinate system or coordinate geometry are measured in units. So the area will be in square units. So the correct choice is A. A is the correct choice. Now, if I am doing any kind of calculation mistake in finding the lengths or the coordinates of any point or applying the concepts incorrectly, then please feel free to let me know in the comment section. I will highly appreciate that. And if you have any query regarding the concepts I am applying or regarding any step, then also let me know. I will do my best to help you out. Let's see the next question. Question number 2. The distance between the reflections of the point P in the coordinate axis is. So it is asking to find the distance between the images of this point P in the x-axis and y-axis. So let's first draw the coordinate axis. X dash origin O x, y O y dash. Okay. Let's plot the point P, which is minus 3, 4, which the abscissa is negative, that is, it will be on the negative side of the x-axis or to the left hand side of the y-axis, and it will be, the point P will be at a distance of 3 from the y-axis. So roughly, let's say, and it will be, the ordinate is 4, which means it will be in the positive direction of the y-axis and at a distance of 4 from the x-axis. So let's say roughly this be the point P. I think this is the same point as the previous question. Yes. Okay. So so the distance between the reflections of the point. Acha, okay. So what will be the as the previous question, the image of the point P, let's say this be the point P. The image of the point P in the x-axis will be over here. It is Q. It will be minus 3, comma minus 4. The image of the point P in the y-axis will be somewhere here. Let's say R. It will be 3, comma 4. Okay. Now we have to find the distance between Q and R. Q and R. So what basically? So what is the distance between? Okay. Now there is a formula to find the distance between 2 points. The formula is that if you know the coordinates of 2 points, what is the, how will you find the distance between those 2 points? So the formula is square root of square of the square root of. Okay, so the formula is, let's say I'm directly writing the formula to find the distance between the points Q and R. So QR will be equal to square root of the square of the difference of the abscissa of the points Q and R, which will be 3 minus the difference. You can consider either the difference of the abscissa of the points Q and R, you can consider it as abscissa of R minus abscissa of Q, or abscissa of Q minus abscissa of R. In both way it will be correct. So if I write the difference of the abscissa of R minus Q, it will be 3 minus 3, because anyway we will have to take the square, so it won't matter. Square of this, that is the square of the difference of the abscissa of the 2 points plus the square of the difference of the ordinates of the 2 points, which will be the ordinate of R minus ordinate of Q is this, and square. So this will be square root of 3 minus 3 is 3 plus 3 is 6, and 6 square. So this is 6 square plus 8 square. This is 36 plus 64. This is square root of 100, which is equal to 10 units. So the distance between the points Q and R, Q is the image of the point P in the x-axis, and R is the image of the point P in the y-axis, and the distance between Q and R is 10 units. The correct choice is D. So the formula applied was to find the distance between the points Q and R, it will be square root of, and then inside the square root there will be we will add the square of the difference of the abscissa and the difference of the ordinates. Okay, let's see the next problem. Question number 3. The quadrilateral formed by joining the points, 4 points are given, A, B, C, D, in order is a, okay. So let's see, let's roughly plot the points on the coordinate axis, Cartesian coordinate axis, y origin, y dash, x dash origin x. The points are A is the coordinates is 0, 0, which means it is the origin. So this is the point A. This is A, 0, 0. Even though the point origin, the point having coordinate 0, 0 is always denoted by the origin O. B is 5, 0. The ordinate is 0, means it will lie on the x-axis, and x abscissa is 5, positive 5, which means it will be on the positive direction of the x-axis. So somewhere over here, this is B, this is 5, 0. C is 3, 2. So 3, 2, definitely from the coordinates you can see both the abscissa and the ordinate are positive. It will be in the first quadrant. So C will be at a distance of 3 units from the y-axis towards in the positive direction of the x-axis. So let's say if B is 5, roughly 1, 2, 3. Okay, roughly this could be C. This is no, this is not C. Okay, so this, let's say this B, roughly this B. Let's do some divisions so that we can plot the points properly. So B was 5, 0. Okay, so 1, 2, 3, 4, 5. So this is the marking of 1, 2, 3. This is the marking of so this point is 3, 0. Okay, the point C is 3, 2, means the ordinate is 2, means it will be at a distance of 2 units from the x-axis, and it will be in the positive direction of the y-axis. So roughly over here, this is the points C 3, 2, and the point D is 0, 2. X coordinate or abscissa is 0, means it will lie on the y-axis, and ordinate is 2, means it will be in the positive direction of the y, and it will be at a distance of 2 units from the x-axis. So this is a D. This is 0, 2. Now you see, so if I okay, so the quadrilateral formed by joining the points. Okay, so the quadrilateral is AB. So this is the quadrilateral A, B, and then C, and then D. Okay, now clearly this is not definitely we can see this is not a rectangle or this is not a square. It could be a trapezium only if we can prove that two opposite sides are parallel. It can be trapezium if I can prove that one of its two sides are parallel. Clearly we can see that DC will be parallel to AB, but why? You see that obviously the points A and B, the vertex A and B, or the side AB is lying on the x-axis. Okay, now the points, the vertices D and C, they both have the same ordinate 2. So when 2 points have the same ordinate, let's say we have a point P, it is let's say x1 comma y1, and there is another point Q, another point Q, let's say x2 comma y1. So the point P is x1 comma y1 and point Q is x2 comma y2 y1. Both the points P and Q are having the same ordinate y1. This will imply that the line segment PQ will be parallel to the x-axis. Any two points, the line segment joining any two points having the same ordinate, it will always be parallel to x-axis. So DC is parallel to x-axis, means that AB, the DC will be parallel to AB. So clearly this is a trapezium. This is obviously a quadrilateral because it is having four vertices ABCD, and obviously the side AD is not parallel to BC. If AD was parallel to BC, it would have become a rectangle. But BC is not parallel to AD because BC for the line segment for the side BC, if to be parallel to the y-axis, the x coordinate or abscissa of both the points C and B has to be equal, but they are different. Abscissa of C is 3 and abscissa of B is 5. So they cannot be, the line segment joining B and C cannot be parallel to y-axis. Similarly, if two points have the same abscissa and different ordinates, it doesn't matter, and different ordinates, then the line joining those 2 points is always parallel to y-axis. So the correct choice is, it is a trapezium. Choice C is the correct choice. Question number 4. The distance between the points is, so we can apply the straight, okay, one thing before applying the formula of this. So we know that the direct formula for finding the distance between 2 points, let's say x1 comma y1 is a point, and let's say there is another point q, x2 comma y2. We don't know anything about x1 y1, x2 y2. So the direct formula is pq, that is the distance between these 2 points p and q, will be square root of square of the difference of the abscissa of the 2 points, that is x1 minus x2. You can also consider x2 minus x1, it will make no difference. x1 minus x2 is the difference between the abscissa of the 2 points, their square, plus the square of the difference of the ordinates of the points. y1 minus y2 is the difference of the ordinates of the 2 points p and q and its square. So this is the direct formula to find the distance between 2 points when their coordinates are given. But before applying this formula, you must see whether the 2 points are having same ordinates or same abscissa. In this problem, we can see the point A and point B are having same ordinates, same ordinate. So in that case, the distance between the point A and B will be the absolute value, the absolute difference between the abscissa of the 2 points. So the concept is, let's say if the point P and Q were like this, x1 comma y1, and they are having the same abscissa but different ordinate, then PQ, the points P and Q are having same abscissa, that is x1, but different ordinates y1 and y2. Then what will be the distance P and Q? What will be the distance between the points P and Q or the line segment PQ? It will be the absolute value of the difference of the ordinates y1 minus y2. This thing, so you have to quickly, before applying this formula, which is little time consuming, you must quickly check whether the 2 points are having the same abscissa or they are having the same ordinates. Similarly, let's say if the 2 points are such that they are having the same ordinate but different abscissa, they are having the same ordinate, that is same y coordinate but different abscissa, then the distance between them will be the absolute difference between their abscissa, x1 modulus of x1 minus x2. x1 minus x2 is the difference between the abscissa of the points P and Q and their absolute value. This is the mod operator, absolute value or the numerical value of x1 minus x2. So in this problem, the distance will be absolute value of the difference of the abscissa, which is minus 5 minus 7, which is equal to mod of minus 12, which is equal to 12. So the correct choice is C. C is the correct choice. Let's see question number 5. If the point P 4, 2 is translated parallel to the x-axis through 8 units, then the coordinates of new position of P are, okay. So let's see, let's draw the coordinate axis. X dash origin x, y origin y dash. So the point P is 4, 2, which means both abscissa and ordinates are positive, which means it will be in the first quadrant. So it will be, the point P will be at a distance of 4 units from the y-axis in the positive direction of y. So let's say this marking is 4, and let's say the ordinate is 2, which means it will be in the positive direction of y and at a distance of 2 units from the x-axis. So let's say this. So this will be the point P 4, 2. Okay. Now this point P is being translated parallel to the x-axis through 8 units. Now, parallel to the x-axis, translated parallel to the x-axis means it will be is translated along the line which will pass through the point P and which is parallel to x-axis. So let's say this is a line which is parallel to x-axis and passing through the point P. So the point P is being translated along this dotted line, which is a line parallel to x-axis and passing through the point P. Now the point P can be translated either to the left hand side or to the right hand side. If it is translated to the right hand side along the dotted line through 8 units, then obviously let's say somewhere over here this P dash, then the new position of point P will be since it is translated along the dotted line which is parallel to x-axis, which means its distance from the y-axis will increase by 8 units. So the abscissa will become 4 plus 8, which is 12, but the ordinate will be same because the point P is translated along the dotted line. And the dotted line is always at the same distance from the x-axis, which is 2. So 12, 2 will be the coordinates of the new position of point P if it is translated parallel to the x-axis along the positive direction of the x-axis. Now, if the same point is being translated towards the left hand side, then by 8 units, then it will be the point P is already at distance at 4 units from the y-axis. So if it is translated to the 8 units to the left hand side towards the left, it will be somewhere over here. This is, let's say, P double dash. Now P double dash and P, the total the distance of P double dash and P is 8 units, and P is a distance of 4 units from the y-axis. So definitely the distance of P double dash from the y-axis will be 8 minus 4, which is also 4. But since it is on the now on the negative direction of the x-axis, its abscissa will be minus 4 and the ordinate will be same because it is still lying on the dotted line. So minus 4, 2. So the new position of the point P can be 12, 2 or minus 4, 2. So the question is asked, then the coordinates of new position of the P are, we do not see minus 4, 2, but we see 12, 2. So C is the correct choice. But remember that another possible position of the new position of the point P can be minus 4, 2. Okay, let's see the next problem. Points minus 1, minus 1 and 7, 7 lie on the bisectors of the, okay, so we need to understand what is meant by the bisectors of two quadrants. So let's say let's draw the coordinate axis. This is x dash, origin x, y, origin y dash. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Now what is the okay, what is the bisector of quadrant 1 and 2? Points lie on the bisectors of the first and second quadrants. Bisectors, okay, of the. Now what is the bisector of first quadrant? It will be basically the first quadrant is, you can say, YOX. YOX, the region YOX is the first quadrant. So YOX, angle YOX is 90 degree. The bisector of the angle YOX will be something like this. So this is the bisector. And this bisector will also be, if I extend this line, if I extend this line, this will also be the bisector of the third quadrant. So bisectors of first and third quadrant is the same, and the bisectors of second and fourth quadrant is the same. Second and fourth, okay. Okay, so these are the bisectors. We have two bisectors. Let's say the bisectors of the quadrant 1 and the quadrant 3 is the line AB, and the bisector of the quadrants 2 and quadrant 4 is the line, let's say, CD. Now let's see let's see where will the points -1, -1 will be. So -1, -1, notice that both the points are having the same abscissa and ordinate. That is x coordinate and y coordinates of both the points are same, which means that the points -1, -1 and 7, 7 will lie on the line AB. The line AB, equation of the line AB is y equals to x. The angle bisector, the bisector of the first and third quadrant, it is the line AB, and it will pass through the origin O, and obviously this is 45 degree. These two angles are 45 degree, and the equation of this line AB will be y equals to x. So clearly we can see that the points -1, -1 and 7, 7 will lie on the line AB, which is the bisector of angle of the quadrants first and third quadrant. So the correct choice is C. C is the correct choice. Now the other bisector CD, what will be the equation of the other bisector CD? Its equation will be y equals to -x. Y equals to -x will be the equation of the bisector of the second and fourth quadrant, that is the line CD. And clearly the points -1, -1 and both the points -1, -1 and 7, 7 will not lie on the line y equals to -x, because these 2 points will not satisfy this equation. So always remember that the angle bisector of first and third quadrant is the line AB, which is passing through the origin O, and its equation is y equals to x. And the bisector of the second and fourth quadrant is the line CD, which is also passing through the origin O, and its equation is y equals to -x. Let's see the next question. Question number 7. The image of a point P under reflection in the x-axis has the ordinates 7, -3. The coordinates of P are, okay. So the image we don't know the coordinates of point P, but its image in the x-axis is given. From the image, how do I know what will be whose point is the image in the x-axis? So remember that if let's say, okay, let's draw the Cartesian coordinates x dash O origin x, y origin y dash. Now the point P is 7, -3. Where will it be? The abscissa is 7, which means it will be in the positive direction of the x, that is to the right hand side of the y axis, and it will be at a distance of, sorry, it is the image. Let's say the image of the point P is Q. So the coordinate of Q is given as, the image of the point P in the x axis is given as 7, -3. Let's try to plot the image first, which is whose coordinate is given as 7, -3. So 7, the abscissa is 7, which means it will be at a distance of 7 units from the y axis, okay, and the ordinate is -3, which means it will be at a distance of 3 from the x axis, but since ordinate is -3, it will be in the negative direction of the y axis. So somewhere over here, let's say this is the point Q, the image of the point P, whose coordinate is given as 7, -3. So Q is the image of the point P, whose coordinates we do not know, in the x axis. So if Q is the image of P in x-axis, then obviously P will also be the image of Q in the x-axis. This is the concept. If A, if A, if the image of A, if the image of A in x-axis is the point B, then obviously it will mean that the image of point B in the x-axis will be the point A. Now to find the coordinates of the point P, I just need to find the image of the point Q in the x-axis. So obviously it will be the point Q, its image will obviously be in a line which is parallel to the y-axis and passing through the point Q. So let's first draw a line parallel to y-axis and passing through the point Q. This is the dotted line which is parallel to, let's say this line be PQ. The line PQ is parallel to y-axis and passing through the point Q. Sorry, the line cannot be PQ. Let's say the line is, let's say RS. RS is the line which is parallel to y-axis and it is passing through the point Q. Why? Because I have to find the image of the point Q in x-axis. To find the image of a point in the x-axis, I need to draw a line parallel to the y-axis and passing through the point. Now the image of Q will be on this line, on this dotted line, and at a distance of 3 units from the x-axis and to the other side of the x-axis. So somewhere over here this will be P, which will be, whose coordinate will be the x coordinate of P will be the same as the x coordinate of the point Q, 7, but its ordinate will be, since now it is in the positive direction of the y and at a distance of 3 units from the x-axis, its ordinate will be 3. So the coordinates of the point P is 7, 3 and the correct choice is A. A is the correct choice. Let's see the next problem, question number 8. If points P 3, 0 and Q A, 0 are equidistant from the origin, then value of A is, we can see that both the points P and Q are having ordinate 0, which means both the points P and Q lie on the x-axis. Let's draw the Cartesian axis. Cartesian coordinate axis, x dash origin x, y origin y dash. The point P is 3, 0, it will lie on the x-axis as the ordinate is 0. The abscissa is 3, which means it will be at a distance of 3 units from the y-axis and it will be in the positive direction of x. Okay, so let's say this be P 3, 0. Now the point Q is also, the ordinate of the point Q is, the coordinate of point Q is given as A, 0, which means ordinate is 0, which means it will lie on the x-axis. The point Q is also lying on the x-axis. Now it is also at the same distance from the origin. The point P is at a distance of OP. The point P is at a distance of 3 units from the origin O, and the point Q, where can the point Q be? It will lie on the x-axis and its distance from the origin will be same as 3 units. Now the point Q cannot be the point P. P and Q are different points. So the only way that the point Q can lie on the x-axis and still having a same distance of 3 units from the O of the origin is that it will be the image of Q has to be the image of P in the y-axis. So Q will be somewhere over here and its coordinates has to be -3, 0. Remember that a point, if a point A is, if A and B are 2 points which are image of each other in the x-axis, then the distance of the points A and B from the x-axis are same. They are equidistant from the x-axis if the points A and B are images of each other in the x-axis. Similarly, if 2 points are images of each other in the y-axis, then the distance from the y-axis is same. So the only way, and the point Q cannot coincide with the point P. So the only way where the point Q can lie on the x-axis and will be at the same distance of 3 units from the y-axis, it has to be the image of point P. So clearly the coordinates of the point Q is -3, 0. Then clearly this implies that A has to be equal to -3. So the correct choice is B. B is the correct choice. Let's see question number 9. If the point P, x, y lies in the fourth quadrant, then we know that in the fourth quadrant, x dash O, x, y, O, y dash. In the fourth quadrant, we know that all the points in the fourth quadrant, they are in the positive direction of x but in the negative direction of y. So if there is a point P, the point P lying in the fourth quadrant, its abscissa or x coordinate, since it is lying on the positive direction of x, x has to be greater than 0. But since it is lying, the fourth quadrant is in the negative direction of y, the ordinate of the point P has to be negative. So y has to be less than 0. Okay. So now if x is greater than 0, and y is less than 0, what we can say? Then these two facts, which choice will be correct based on these two facts, that x is greater than 0 and y is less than 0. X is greater than y. Obviously x will be greater than y because x is a positive number. X greater than 0 means it will be a positive number, and y less than 0 means it will be a negative number. So obviously a positive number is greater than a negative number. So correct choice is A, but let's see what about the other choices. So B cannot be because x is not less than y. X is greater than minus y. X is greater than minus y. Now if y is less than 0, minus y will be a positive, and we cannot say for sure that x is positive and minus y will also be positive, but we cannot say for sure whether x will be greater than y or not. Similarly, y is negative, and since x is positive, negative of x will be negative, then we cannot say whether y will be greater than minus x or not. So clearly A is the correct choice. Let's see the question number 10, the last problem. If mod x is greater than 0 and y is less than 0, then the quadrant in which the point representing x, y can lie are. Okay, so it is given, let's say P is a point x, y having abscissa x and ordinate y, and it is given that the abscissa, that is mod x, absolute value of x, is greater than 0. What we can say about x when we know mod of x is greater than 0? This implies that x is greater than 0 or x is less than 0, or you can say that x is not equals to 0. These two, x not equals to 0 is same as saying x greater than 0 or x less than 0. So what we can say? And it is given that y is less than 0. Y is less than 0. Okay. So let's see. Origin x dash x y o y dash. Now if y is less than 0, in which quadrant the point x, y can lie if y is less than 0, that is ordinate is less than 0. Ordinate less than 0 means it is in the negative direction of the y. So the two quadrants which lie in the negative direction of y are quadrant 3 and quadrant 4. The fact that y is less than 0, that is the point P is having coordinate x, y and if y is less than 0, that is ordinate less than 0, means that point will lie in the negative direction of the y-axis. So the quadrants in which the point P can lie will be 3 or 4, because the quadrants 3 and 4 is in the negative direction of y-axis. Now we have to choose between quadrant 3 and 4. It is given that what do we know about the abscissa x coordinate x? We only know that x is not equal to 0. That is, the point P will not lie in the y-axis. X equals to 0 means the point will lie on the y-axis. So it is not lying on the y-axis. So obviously we can say that the point P should lie in either quadrant 3 or quadrant 4, because in these two quadrants only all the points have ordinate less than 0. So the correct choice is C. C is the correct choice. I hope solving these problems are from the supplementary problem book, which is MCQs in Mathematics of class 9 of author R.D. Sharma. Solving this problem, I hope you will have a good conceptual clarity of how to apply the concepts of coordinate axis, the points, and all the concepts and formulas based on this chapter of coordinate geometry to solve these kind of problems. But I am planning to make a couple of videos where I will be discussing the key concepts and formulas which are very, very important to understand from this chapter of coordinate geometry. So I have completed problem solving from this chapter of coordinate geometry. Now in the next 3 or 4 videos, I will discuss about the key concepts and formulas which are very essential to understand to solve this kind of problems. So please stay tuned for those videos to come soon. If this video was beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I am ending the video here. Thanks for watching, and until the next video, take care and bye.